I will explain the porosity measurement lab of conventional core analysis of petrophysics course. So porosity measurements depends on to calculate the fraction of bulk volume of the reservoir that is not occupied by the solid framework of the reservoir. So porosity is the percentage of pores in terms of or with respect to the bulk volume of the samples. The porosities of petroleum reservoirs ranges from 5% to 40%, but most frequently are between 10 to 20%. According to this definition, the porosity of pores of porous materials could have any value, but the porosity of most sedimentary rocks is generally lower than 50%. Now we will talk about the factors governing the magnitude of porosity in clastics. Simply, the first one will be the uniformity of grain size. If we have an L-sorted sample, so we can imagine that the grain size which have lower size than from the higher one, it can enter to the porosity and to reduce the porosity percentage. While the well-sorted part, we can preserve their porosity values. So the second one is degree of cementation. Logically, as the degree of cementation or consolidation increase can affect on the pore size and pore throats and can affect badly or negatively on both the porosity and permeability values. Cementing materials include calcium carbonate, magnesium carbonate, iron sulfides, limonite, hematite, and especially hematite, which like the samples of Paleozoic and dolomite, calcium sulfate, clays, and many other materials, including any combination of the materials. Number 3 and number 4, both of them are related to each other. They talk about amount of convection. Besides that, the number 4 talking about methods of packing. We can imagine that the methods of packing, we have the most common one, which is called cubic packing. Cubic packing can have porosity reaches to 35%, and by convection, this type of packing can transfer into rhombic packing like that, which can reduce the porosity to 27%. Now we have two types of classification of porosity. The major two types are the engineering classification and geological classification. The engineering classification can be divided the samples into, or the porosity inside the samples into total porosity and effective porosity. Total porosity including all types of porosity, regardless of whether or not those void spaces are interconnected. While the effective porosity, it is throws the light on the interconnected porosity. So if we have two grains like that, so we have this part of porosity, but this pore is isolated. While if we have this type of porosity, we have this bridge which called pore throat, can connect two types or two neighborhood pore spaces. So the left one, or the left example, is the effective porosity, while the right example is the isolated porosity. Both of them can represent the total porosity. Now we will talk about geological classification. Geological classification divided the samples or the porosity inside the samples into two types: primary porosity and secondary porosity. We can conclude that this classification comes from the time of forming this porosity. So if the pore space is formed centripositionally during the time of deposition of this sample or these reservoirs, the porosity will be called primary porosity, like intergranular porosity, intragranular porosity, and so on. Secondary porosity, from the name, we can conclude that this porosity formed after deposition. We can call it post-depositional porosity, like fractures and vugs. Now we will talk about saturation. If the porosity is the percent of pore spaces with respect to the bulk volume of of the sample. So the saturation is the percentage of or the volume of certain fluid inside pore spaces with respect to the whole value of the pore spaces. So the saturation of water will be the volume of water with respect to the volume of pore. We can conclude that the summation of all types of saturation can give us 100 or 1 value that represent to the 100% of porosity. So the VO plus VG plus VW equal V pore. Now this example, a clean and dry core sample. Weighting 425 gram was 100% saturated with a 1.07 specific gravity prime saturation. The new weight is 453 gram. The core sample is 12 centimeter long and 4 centimeter in diameter. Calculate the porosity of the rock. So easily we can to calculate porosity we need to have both V pore and V bulk. Simply V bulk can get from or can get calculated from the volume of cylinder because the sample need to be in a cylindrical shape. This value is R and this value is height, and I have long which represent height and 4 diameter which represent 2R. So simply I can get V bulk. The pore volume is can be calculated from this law. Simply, if I have the weight after saturation, the weight before saturation, if we subtract them, I can get the weight of the fluid that enters the pore spaces and divide it by the gravity or density. So weight over density, I can get the volume of fluids that enter to the pore space or that already presence in the pore spaces. So easily this is represent the pore space volume, and now I can use the simple equation of porosity to get the porosity equal V pore or V bulk. Now I will describe some descriptive statistical parameters such as mode and median and standard deviations. Mode is the peak value of this population with the most frequently value that can repeated and can represent this population, while the mean is the arithmetic. The most familiar one is the arithmetic mean is the sum of the individual values over total number of values. Standard deviation represents how much this data is dispersed. Simply, if we have two graphs, one of them like that and the other one is like that, we can find that they have the same mode, maybe the same median, or mean, but they different in dispersion or in variance or in standard deviation. So the standard deviation can give us a precious information like heterogeneity and homogeneity. This curve represents the most homogeneous reservoir, while this is so heterogeneous because it is more dispersed. Now I will talk about variance, which is the square of standard deviation, and the median is values that can divide the samples into two categories or two parts from the midpoint. If we have a cumulative curve like that, it will be from 0 to 100, and this is classes. I can get the median value from at 50%. This is the median value that divided the samples into two parts. This graph shows a cross plot of cumulative frequency with random variables x. In this slide we can show how to calculate mean and standard deviation manually. The first step is to calculate or divide the porosity samples into 8 classes by interval of 2, and then this column calculate the frequency Fi inside each class. Then calculate the summation of Fi. This is the summation of Fi. This value represents the lower part of this fraction. Now I will calculate Xi, which represents the midpoint inside each class. This is something theoretical or routine. Now I will calculate Fi times Xi and get the summation of this column. This value represents the higher part of the this low numerator. So easily I can get mean of porosity. Now I will calculate the variance. Variance to get this numerator part. Simply I will subtract xi minus mean. Then I will square this column. Finally, I will time this column by fi to get this final column, and finally I will get the summation of this column, and this value represents the numerator. And I already have the denominator, so I can easily get the variance sigma square. To get standard deviation, I will calculate the root mean square of this sample.